Hello, my name is Raimundo Teive. I'm a co-author of this paper, and I'm going to present the paper Identification of Abnormal Behavior in Activities of Daily Life using Novelty Detection. This presentation is divided into 5 parts: the introduction of the problem, the objective of the paper, the proposed methodology, some results, and the final remarks. The number of older people has increased significantly in the last decades. It's due to the improvement of the life quality and population longevity. It's expected that the proportion of over 60 population will duplicate in the next 3 decades. In relation to the over 80 population, it's expected that the proportion will triplicate in the same period. Since chronic disease such as hypertension, heart disease, depression, and the Alzheimer's disease have affected about 80% of the elderly, it's very important to develop solutions to mitigate the effect of this disease on the elderly. In this sense, ambient-assisted living AAL technologies enable to minimize the difficulty of older people to carry out some domestic activities, and this kind of activities is called activities of daily living, ADL. AAL technology aim to develop personal health and remote monitoring systems. Monitoring the activities of daily living is essential to identify possible abnormalities in these activities, since significant changes in the elder's routine can represent a decline in physical or mental health. Then, the detection of this kind of pattern or behavior allows family members or nurses to be aware of the need for intervention. Human activity recognition or novelty detection techniques can identify a pattern of typical behavior, and from this pattern, it's possible to detect abnormalities. So, the main aim of this work is to identify possible abnormalities in the elderly activities of daily living by using novelty detection technique. In this case, we have implemented 2 kinds of algorithms: the one-class support vector machine algorithm and the local outlier factor algorithm. Now I'm talking about the proposed methodology. The proposed methodology is represented in this flowchart. The initial data set based on the eHealth dataset is used to train the model, searching for identifying the baseline pattern, the baseline behavior of the elderly. This dataset has 20 weeks of data involving 21 daily activities of elderly. Then, in this case, we have used 12 weeks to train the model and 8 weeks of data to test the model. After the training process, the used novelty detection algorithms can classify the elderly activity into two classes, normal or abnormal activity, label -1 and 1, respectively. It's important to emphasize that in machine learning process, you need to make, first of all, a pre-processing phase. In this case, the pre-processing phase involved the calculation of two attributes, the activity duration and the ratio between duration and activity frequency. The used dataset, eHealth, has 21 different elderly activities, but here I'm showing just 10 activities considered in this work. As example, eating, change clothes, take shower, washing face and hands, hair dry, make hot food, toileting, sleep, take medicine, and watching TV. Here it's possible to see the difference between the normal behavior in relation to the daily activity and the abnormal behavior. In red, you can see the abnormal behavior. And in blue, you can see the baseline behavior or normal behavior. In this case, we are considering only 9 activities and the duration attribute. When the other attribute is considered, the ratio between duration and frequency, instead of only duration, the curve is presenting this figure. It's possible to see again that there is a huge difference between the normal behavior and the abnormal behavior. Here the normal behavior is in blue, considering 9 activities as well. The original data set has a raw format here in the A figure. So in the first stage of the pre-processing, data pre-processing, we have to calculate the duration of each activity, daily activity, and the ratio between duration and frequency for each activity day by day. It's the first stage of the data pre-processing. After that, it's possible to build a CSV file considering only the duration here, a figure, and only the ratio between duration and frequency. This file is ready to be used in the algorithm's input. As a result, here we I show some results and discuss some conclusion about the results. For comparing both algorithms, the SVM and the local outlier factor algorithm, we used two types of metrics, the accuracy and the F1 score. Here in the first figure, it's possible to see in this figure here, the accuracy. It's possible to see that the local outlier factor algorithm had a better performance, taking into account both metrics, accuracy and F1 score. In this case, the attribute ratio between duration and the activity frequency seems to be more appropriate to identify abnormalities in both situations, here and here. Another point to be emphasized in relation to these results is that the number of weeks considered in the training affected directly the algorithm's performance. As you can see here, the SVM algorithm needs at least 12 weeks of data to reach the highest values of accuracy and the F1 score. On the other hand, the local outlier factor needs only 7 weeks of data to reach the highest values of accuracy and F1 score. So, in this case, considering the used data set we have, it's possible to say that the local outlier factor had a better performance than the SVM algorithm. Thank you very much for attention. Bye.